video for Artificial Intelligence Assignment 1, 8 Puzzle Solver. I'm going to run my code to show you guys it works. And we're going to play in hard mode and do a A-star search and with the customized heuristic. And here's the result. Now here's the code I wrote. This is the solver class with the function solve. I'm going to get a search algorithm and store do a search from a start state to go state, store the result, and calculate the time cost for the search, and get the path from a start state to go state and print the result. And here's the data structure I use. The game board represents a node. It contains a parent node, array of integers which represent the state and the current cost, the previous operation, and the heuristic. And here's the setters and getters and some helper function. So here's the game board manager. So I'm have a hash table to make sure I only have one state. I only have one reference to one state. And here's the successor function, and the parameter is a game board, and it's going to use the game board and return a possible path to another state. So if it can move up, then get the state after moving up, and vice versa for down, right, and left. And the move function, so these are used to check if the current state is able to move up or down, left, right. So here's the move function, which returns a new state, a new game board. I'm gonna copy the current game board and get the current state and get current 0 position and swap the 0 position with the up, left, up, down, left, or right. If this game board already contains a state after swapping, if it doesn't contain the state after swapping, then I'm going to create a new game board and initialize the parent, the current state, the game board state, the parent game board, the operation, and the current cost. And I'm going to return the game board. And if otherwise, it means we already have a state in the game board manager. We're just gonna pass back that reference for the game board object. So now I'm just gonna talk about A-star search. So I'm using a priority queue to store all the game boards and a hash set of integers for to check if the state is visited or not, and a maximum queue size to check the maximum queue size. And also I need a comparator to compare all the game board in the priority queue. You're just comparing the not in position variable in the game board object, and have a clear function to clear all the data to do a new search. So this A-star search 1 with a heuristic of a number of tiles that are not in correct position. So first I need to clear the priority queue and hash set, and then get the fn for the start state. I'm gonna show you guys the heuristic function I wrote. So I'm gonna update the start state and put in queue while the queue is not empty, and update the maximum queue size. Get the first thing, get the first game board or the game board with the lowest heuristic of the queue. Mark that visited. And for the current game board, I'm gonna get all the possible state, and for each state, if it's already visited, if it is not visited, then check if it is a go state. If it is a go state, then I'm gonna return uh, the go state, so I can track the path back to the parent. If it is not the go state, then we're gonna calculate the heuristic, the FM for the current game board, and we're gonna add the heuristic to the current cost to get the FN, and we're gonna set the FN, and finally we're gonna add the child to the queue, and goes back to the loop. And the A star search 2 and 3 are basically the same thing. So I'm gonna show you how I did the customized heuristic. And here's the heuristic, customized heuristic called by A star search 3. So this function needs two helper functions. The first one is get tile position, which returns the tile position, returns a certain tile position in a state. So if you want to get from current state to go state, then you need the current tile position and the go state tile position. And the get Manhattan distance gonna return the cost. And here's the function I wrote to calculate the Manhattan distance. Okay, that's about it. And if you want to run the program, you just need to, if you have a Java on your machine, then just do a Java C on the main Java file, and then call and then Java main to start the program. All right, thank you for watching.